Welcome to the exciting sequel to integer addition. This one is all about subtraction or taking away integers. Let's do a little review in case you missed the exciting first video. Integer is simply all whole numbers, including negatives, no zeros. Or zeros, yes, zeros. Sorry, got confused there. So, for example, there's an integer, there's an integer, there's an integer. Get the idea? Whole numbers, no fractions, no decimals. Okay, we also talked about zero pairs. What's a zero pair? Any pair of integers which, when you add them together, equals zero. For example, there's a zero pair, there's a zero pair, right? A positive and a negative. And finally, a neutral field, which is more than one zero pair. So if I have 3 zeros, it's really 1 0, right? Because 3 times 0 is still 0. This is called a neutral field. All right, so we're back in action. It's time to get a fresh pen, and it's time to work on subtracting fractions. So you see what I'm doing here. Whew. All right. Make sure it works. It does not. We'll go with the dry pen. All right. So let's say you have a problem like this. 5 minus 2. Now we learned last time all about buying integer tiles. They're also called tile spacers at Home Depot or Lowe's. Buy a bag of them. They all look like this. You can take scissors and carefully create some negatives simply by, and be careful. Okay, you can create negatives simply by cutting the little sides off of a positive. Hey, there's a zero pair. Anyway, we can represent integers with these. I think it's a nice concrete hands-on way, which you can also draw onto your paper. Anyway, there's 5. I'm going to subtract 2. What's the answer? 3. Of course, you already knew that, but we're using this simple problem to demonstrate how this works, so don't worry, okay? And on paper, you simply, to show subtraction, you draw the first thing in the expression. This later becomes an equation. Then you circle and maybe draw a little arrow to show that something's being taken away. And what's left is the answer, which in this case was 3. Okay, so that's simple if you're using all positives. Excuse me, if you're using all positives. Let's say you're using negatives. Let's try that. Negative 4, take away negative 2. Well, start with negative 4, right? We can draw that. You're free to draw stuff on tests. You know that, right? You can use visual aids. It's not a crime. There's negative 4. I'm going to take away negative 2. So I'm going to find negative 2 here. I'm going to draw a little arrow to show it's being taken away. What's left? There's the answer, negative 2. Right? And visually you can see you literally take them away, and that's what's left. Okay, now let's do some tricky ones. Whew. First of all, I need you to tell me, what's this? That is 2, right? Now, here it gets tricky. What is that? Well, it's still 2, right? All I did was add a neutral field. Neutral field just means that's 0. So this is 2 plus 0. This is still 2. It just looks different. Okay, this becomes very important here in just a second. Okay, so we're going to take a problem that starts with a negative and takes away a positive. Negative 3, take away 2. All right, so follow all the rules. Start with negative 3. Very good. Then it says to take away positive 2. Look at my picture. There's no positives to take away here. And this is where people get stuck and get wrong answers. Here's the beautiful thing. If I add zeros until I have 2 that I can take away, now I can take it away. So if I redraw a -3 to look like that, would you agree that is still -3? Of course you agree. But now the cool thing is I have 2 positives that I can take away. And what's left is the answer, which is -5. So I started with 3 negatives. I took away 2 positives. It's like magic. I took away something that's not there through the magic of 0 pairs. And it reveals the answer quite easily, right? You take them away, there's the answer. So cool. Let's do another one. I'm going to start with 5 positives, and I'm going to take away 2 negatives. Okay. People get mixed up here. They might get an answer like 3 or something. Don't do that. So there's 5 positives. You could draw it. If you don't have, remember, if you don't have the tile spacers, you can draw this on your paper if you remember the representation here. But I need to take away -2. That just sounds ridiculous. But if you remember, all we have to do is add 0. That is still +5. Do you see how this is still 5? This is just 0 over here. Add it to my picture. That is still 5. Okay? But now the cool thing is I can take away -2. And there's the answer, right? Take them away. You can see the answer. You can touch and count the answer. It's so cool. I love this. All right. That is how we do subtraction with integers. And hopefully having these things in your hand and making drawings on your paper makes this easier to see. And of course the goal is, once we're in algebra and you have x's and y's and big numbers and other things going on, you can always go back to these simple demonstrations to remember how things work. This is something you can trust, and it works for big ugly problems too. So that's that. Thanks